Write the Riemann sum and then the definite integral representing the area of the region using the strip zone. Evaluate the integral exactly. Oftentimes, we set up the coordinate axis so that the origin is the center of the circle. The radius of this circle is 3. The equation of the circle is x squared plus y squared equals r squared. R is 3. A representative cross-section or a rectangle is drawn horizontally perpendicular to the y-axis. The area of this rectangle is the length times the thickness, but the length is the horizontal distance w and the thickness is delta y. In this case, given delta h. We then change the y-axis to the h-axis. The vertical distance from the origin to the slice is h. The radius is 3. The horizontal leg in this right triangle is half of the length of the rectangle. It is the distance from the vertical axis to the point x, y. Using the Pythagorean theorem, x squared plus h squared equals 3 squared. Therefore, x equals the square root of 9 minus h squared. And so the length w is 2x, or 2 times the square root of 9 minus h squared. The area of the representative rectangle is therefore the length, which is 2 the square root of 9 minus hi squared, times the thickness, which is delta h. The total area is therefore the sum of ai, but each of ai is 2 times the square root of 9 minus hi squared times delta h, and we recognize that this is the Riemann sum. If we take the limits at n go to infinity or delta h go to 0, this is the definite integral, 2 the square root of 9 minus h squared dh. Since we are adding all of the rectangles along the y-axis or the h-axis, the lower limit of integration is minus 3 and the upper limit of integration is 3. Using symmetry, we can double this integral from 0 to 3. We obtain 4, the definite integral from 0 to 3, the square root of 9 minus h squared dh. And if we were to evaluate the definite integral, we should end up with 9 pi, which is the area of the circle pi r squared, where the radius is 3.